Astronergy. We have Sibin Yang, who is a product solution engineer at Astronergy, and his topic of presentation is dominating the market, efficient and reliable TOPCon modules. Sibin?
So, hello guys, I'm very glad and honored to be invited by TaiyangNews. And today my topic is dominating the market, efficient and reliable TOPCon modules. So let's get started. So firstly, I'll introduce our company, just go through the milestones that we've come across. We established our business in PV industry since 2006, and we've built global manufacturing factories in Zhuquan and Haining and Thailand manufacturing base. And we've gone through the PERC period of time, and now we are a steady believer of TOPCon, and we still make that as our guiding products in the industry. So for us, Astronergy, we have a strong backup force as the Qing Group. They initiate a great enterprise and business in electrical industry, and including power generation and down to power consumption. So we set up food in PV industry, and so we developed our own subordinate company as Astronergy to provide services for utility scale distributed power station, and we try to expand our business all over the world. So this full entire industry chain will help us to be more capable of dealing with new coming challenges. So there are some owners that have been presented. So we have connections with PV magazine tests, TUV Rhineland, PVEL and RITC, or just to say that we have connection with all those authorities and institutes. And just kind of the show off. Secondly, I will introduce the technology trends and how we plan our capacity layout. So this is sourced from the PV Link. So we can see that from 2021 up to down to next year, the proportion of TOPCon modules are increasing and almost dominating the market. There are still some new coming technologies, such as HJT and BC modules. The questions about those two new modules are still coming up, and we still believe that under the mature industry supply chain and or other factors and policies, the TOPCon has already managed to be equipped with inverters and trackers, and to provide a very clear from end-to-end production line, like all transparent to the customers. So a more strong evidence to prove that the TOPCon has already been dominating the market is that we list like the top 10 or 15 mainstream manufacturers who are producing TOPCon modules. And by the end of 2028, we believe that the TOPCon capacity will reach 2K gigawatts, which is almost 5 times HJTs and 20 times of BC modules. So mentioning about other technology trends, we have to say that the cost of different technologies can be different. So we set the baseline as TOPCon, and currently as the production is not that massive enough, so the cost of HJT and BC will still be higher than TOPCon. And although the module price seems to be descent in recent years, but we believe that will be an end. I mean, the module price will not go down forever. So we expect that the TOPCon, as the production is becoming mature, so we are expecting that there's more cost for other technology once they can solve the core problems regarding their production, and like you shifting the devices from the old ones to the new ones. So mentioning all those, giving all those information, but in this year, our TOPCon cell production capacity will increase to 59 gigawatts this year, and will be fully up to 98% by the end of next year. So we are confident to say that we are putting our all efforts in producing TOPCon, and to expand our influence globally, we've set up factories all over the world, in North and South American continents, Europe. By the way, the Turkey manufacturing factories will be put in production this year. So the third point will be the critical point I try to come up today is previously, not long ago, the RETC has some report saying that the TOPCon modules may face a higher risk of UVID problem. But when we actually initialized our production in TOPCon, we've already made our research and study what UVID problem can actually be. So what is that actually is that the energy that ultraviolet comes in will stimulate the hydrogen, and the hydrogen will be gathering at the surface near the passivation and silicon interface. So based on that, the carriers when they come across the surface, they will tend to recombine and hence reduces the open circuit voltage and the field factors. So there are some tests that we've been doing using our under rigorous testing condition. So we've passed the UV60 tests to make that degradation under 1%, which is the extended stress test requirements. So we will say that 0.7% is a very good achievement. So we are also passing the UV 120 and 180. For the higher, more strict testing conditions, the tests are still ongoing. We haven't got the results yet. And we also consider the module test under damp and humidity conditions, which seems to be good among the other tests and the results from the third-party authorities. So the solution to the UVID problem is that we try to optimize the passivation film layer structure design. The first point, we try to improve the density of the film layer. We try to enhance the UV resistance of film layer. I'll try to regulate the hydrogen in film layer. And last but not least, improve the quality of aluminum oxide layer. So we can see that the crucial part is how to improve the quality of film layer. So the things that we did when we firstly look into the UVID problem is that it is our convention to use the plate ALD, which is known as the atomic layer deposition technology. So we've been all using that since the first day we tried to do TOPCon. So the thing is, the front surface of aluminum oxide layer, if they are dense and compact enough, it will stop the hydrogen atoms escaping from the substrate of the silicon. So when the UV comes in, it cannot penetrate that layer easily. The advantage of the ALD technology features and the advantages of ALD technology is that the principle is we put two plates in between so that the gas can only flow in one direction, which makes you can control the gas more easily and more precisely. So the thickness of the film can be precisely controlled by adjusting the reaction cycles with accuracy reaching the thickness of a single atom. It has a high planarity. The bottom-up growth mechanism ensures a pinhole-free surface, so which means that the ultraviolet cannot easily penetrate, which can improve the UV resistance of the film layer. We also have a high conformality. The film layer can be completely consistent with the shape of the silicon substrate, enhancing densification. And it also has good adhesion because the chemical absorption between the pre-surface and the substrate surface guarantees excellent cohesion. That means when one pre-surface comes in, we have to make sure that the monoatomic layer is done and the second precursor can be followed precisely with the previous layer. As you may know, that there are other manufacturers, they tend to use tube ALD technology. So what's the difference? So with a tube, you put the substrates in the tube, but the gas in the tube can go in different directions, which makes it even more difficult to control how they can lay on the substrate. And then that can cause some not homogeneous layer on the substrates. That means the for different parts on the substrates, the UV can be distributed differently. So if there's a one weak spot or area for UV to come in, and the substrate will be totally affected and degraded. So with the plate ALD has thicker uh, aluminum oxide layer, and that is more uniform and has greater density, resulting in stronger UV resistance. And with that production technology, we can also produce in a larger scale and more effectively. So we've also run tests uh, between the plate ALD and tube ALD. It is possible for us to look into, include tube ALD in the future, but as long as it can reach as effective and as strong proof of UV, the same as the plate ALD, we will consider to make a mix of them because there are some manufacturers, they tend to use a mixture of both, but we are now mainly using the plate ALD. So the UV sequence test results indicate that the UV degradation of astronomy high efficiency modules using plate ALD cells has decreased down to 0.93, which is less than 1%. And the quality of the inner aluminum oxide passivation layer is a key factor affecting the UV resistance of the solar cells. So ALD technology can deposit thicker aluminum oxide films, enabling the development of higher quality passivation layers, which fundamentally addresses the issue of UV degradation. So last but not least, I'll talk about some main products that we're using. So for utility scales, we have ASTRO N7. We use rectangular wafer, which increases the bus bar from 11 to 16, which reduces the risk of micro cracks to improve the efficiency of current transmission. And we use the newest technology, TOPCon 4.0, which introduces the laser-induced firing technology. It guarantees a better ohmic contact. And for reliability, we have two-layer higher transmittance glass to prevent water vapor from coming in. And we also attach light directing film at the back of the module, so we can secondly use the phone line incoming and to redirect it to be observed by the cells. Um, talking about the technology, we can also look at the system cost that the technology the system cost advantage that the technology can bring to us. So for our N7 cells modules, we have 66 cell design. We have lower open circuit voltage. So compare with traditionally 72 cells, it allows you to connect two more modules per string. And compare with the high 700 plus high power 210 modules, it is actually narrower. So for some tracker systems, it allows N7 modules to connect one extra more strings. Some people are confused and curious why it is the case, because a longer tracker will have to face the risk of high wind load tests. You cannot easily pass that. So that's the advantage of N7 modules, and it ultimately will give you a lower LCOE. And for residential, we have a smaller product, which is N7s. We have adapt to the zero bus bar design. We have negative gap, no warping. So with a combination of zero bus bar and tiling film, the prefix soldering ribbon with the encapsulation film in cells in one-step process. And ohmic contact is formed under a low temperature, which reduces the risk of high thermal stress. And it also reduces the risk of microcracks at the edge of PV cells. So compared with the previous products, it has higher power output. It contains 20 thin soldering wands and reducing series resistance, smaller shading area, and reduces the optical losses. It also eliminates the cell spacing. So that means you have fewer CTM losses module power output is increased too. And considering the reliability, we use finer and more soldering vials and lower temperature soldering process, the laminated soldering. That's what I talk about. That you can face fewer risk about thermal stress, and the flexible electrical connections between soldering vials and cells, reducing the risk of cell cracks. And soldering flux is limited, improving the DH performance. So that's all come together. We adapt these two products in different scenarios. So for Germany, where the 2 meter square policy is applied, we use a smaller cell with a smaller module for easy installation, and it has high power as well. And for other regions, for Europe, the 3 kilowatts policy, you always want your module to have higher power so that you can put more you can put you can adapt great power with a restricted area of your rooftop. So by that, we will increase the size of the module to provide more power. And I think that's all for my presentation. Have any questions to ask?
Yes, Sibin, thanks a lot for this interesting presentation and really bringing out this UV degradation topic, which is really a hot topic these days. So, I thought I might not have time to ask you questions, so that's why I also put my questions in the chat. So, when you were mentioning film, so you were referring to aluminum oxide film on the top side, right?
Yes.
It is always. And then it's also very interesting because what you said is a plate ALD. So this, I suppose, is a batch, inline batch ALD where you have this carrier and you put the wafers and you process, right?
Yes.
And can you give any example of a equipment maker who is offering such solutions?
I think Jinko use a mix of them because the plate ALD is not that commonly seen like in the market but in other manufacturers, and because honestly the plate ALD is kind of expensive. But when we firstly invest our use the devices, we have already considered how the UVID can affect our modules, so we choose the more expensive methods to proceed the production. So there might be some other manufacturers that use a mixture of them, and some are fully support in tube ALD.
Okay, but one more thing, like now we are hearing about the excuse me, UV induced degradation of TOPCon very much in these days. But TOPCon has been has become mainstream for quite some time. So why UV people are talking about UV degradation now, whereas you say that you already found out about it at much earlier stage?
Okay, so the thing is, as I said, the proportion of the market who adapts a plate ALD is not that common. So I'm not quite sure how the tests are conducted, with what technology that those modules are being tested, whether they are using the plate ALD or tube ALD, because I assume with that great proportion of tube ALD being presented, and that might cause the problems. Like nowadays, because people try to reduce the cost, and they probably try to use more tube ALD like than ever before, and the problems may reveal by now. I can't say for sure, but I think that can be one of the reasons.
Okay. Okay, great. I think there are really a lot of questions regarding your presentation because you really touched on an interesting topic. So please stay back, enjoy our conference, and please answer these questions in the chat room.
Okay, thank you.
Thank you.
Astronergy. Solar together for a greener world.